right? In this video we will see how to insert a new node in a doubly circular linked list. Insertion at beginning, insertion at end, and insertion at any specific position, right? See, this is what a doubly circular linked list. Every node is having three parts. Data part, this pointer is containing address of the next node, and this previous pointer is containing address of the previous node, right? Plus here I am maintaining also tail pointer and head pointer. Head is containing address of the first node, tail is containing address of the last node. Plus one more thing is, see, the next pointer of the last node would contain address of the first node, right? And the previous pointer of the first node would contain address of the last node, right? To make it a doubly circular linked list. This list is having property of both doubly and circular, right? You can see this link is bidirectional link, right? So now we will see, first of all we will see how to insert a new node at beginning of this list. I'll create a new node, right? I'll allocate the memory dynamically using malloc function, and here I will insert that node at beginning, right? So here I assume that you have created this list, means you have called that create doubly circular linked list function, and you have created this list. In this list we have three nodes, right? That we have discussed in the previous video. You can check out that video, right? And now I will create a new node and I'll insert that node here. See now how you will write that thing. See, I hope everybody know how to represent this thing in coding. So this is how we are going to represent this node, right? For this node we will define our own data type. This we have discussed many times in the previous videos. Struct node is the name of that data type. This complete is the name, struct node. Three parts are there: data part, one pointer is next pointer, one pointer is previous pointer, right? So these pointers will contain address of the node. That is why here I am writing struct node, because here we will write what? The data type of that thing whose address we are going to store in this pointer, right? We are maintaining two pointer, head and tail. So suppose we have created this list by calling that create function, and now I am going to define this function in insert at beginning. So now this node, obviously we will have to create a new node, right? So for that thing we will take a pointer new node. See, this thing already we have discussed many times in the previous videos, right? Now we will allocate memory to this node. How you will allocate? A dynamic memory allocation using malloc function, right? See, so the syntax of malloc is, you will write that malloc function, in the bracket you will write how much size you want, size of the name of that data type. Data type name is a struct node, right? And malloc will return what? See, now this memory has been allocated how many bytes? 12 bytes. 4 for this, for integer 4 bytes, for 4 bytes for this pointer, 4 bytes for this pointer, 4 bytes for pointer in 32-bit compiler, 8 bytes in 64-bit compiler, 12 bytes. So this block is of 12 bytes, and this 500 is what? Address of the first byte. So this malloc will return this pointer to the starting address, and malloc will return what? Void pointer. And this pointer, in this pointer we are going to store this address now, but this pointer is what? Pointer to node. So you have to typecast this thing. So how you will typecast? The syntax is you will write that data type asterisk, and this address we are going to store in new node pointer, right? So now suppose address is 500 and we have stored this in this new node. So now new node pointer is pointing to this node. Fine. Now we will ask from the user which data he wants to insert, right? Using printf and scanf. And how you will store that data? See, we cannot directly access these structure members. So in data part I want to store. Now how you will access this data part? The pointer to this node is new node. So using new node, address of the pointer name, here you will write that arrow operator, means how you will write this thing in your, when you will write a C program, hyphen and that angular bracket, right? And here the name of which part I want to access? Data part. So here I will write data. Suppose user has entered here 7. You can insert null or null, but that is of no use, because obviously we are going to update this pointer and this pointer, because in this doubly circular linked list no pointer is null pointer, right? Now see how you will insert this thing here. Now we will check if list is empty. In that case what you will do? See, now we will write a condition if head is equal to 0. It means there is no node in the list. Fine. and this would be the first node, this would be the last node in the list, right? Both head and tail would point to this node. Fine. Now here you will write head and tail would point to this node, that is in head and tail we will store address of this node, that is 500, and this 500 is a new node. Fine. And plus now this would point to itself because the last node is containing address of the first node, and this previous pointer of the first node would contain address of the last node, but this is the first node, this is the last node, right? So here also 500 and here also 500. In case when list is empty, there is no node in the list, right? So now how you will access this thing? Both head and tail and all the 3 pointers, new node is pointing to this node. So you can access these data, these parts using any of these nodes. It's up to you, right? Here suppose I am writing new node previous is equal to tail new node next is equal to head. See, it is not compulsory that you will write these 2 lines here, right? Here you can write head of next is equal to head, head of previous is equal to head, tail of next is equal to head, tail of previous is equal to head, because all the three pointers head, tail and new node would be having that same address, that is 500, right? So it's up to you how you will write this thing. Now else, suppose I have now 3 nodes in the list and now I want to insert this node here. Fine. Now what you will do? See here what you need to update. This would be the first node, right? So now the next pointer would contain address of the next node, that is 200, right? So now how you will access this thing? New node next. So here what you can write? New node next equal to, from where you can get this 200? In head we have 200, so here you can write head. So now here I have 200, means now this is pointing to this node. Next link, now this would point to the previous node, so this previous pointer would contain address of the previous node, so this would be the previous node now. So here how you can access this part? Head of previous. So here what you can write? Head of pre is equal to address of the previous node is 500, from where I can get 500? In new node I have 500, so here I can write new node, right? So now here I have 500, right? So now this is pointing to this node, right? Now you have to set 3 more things. Now this previous pointer of the first node, because this would be the first node now, would contain address of the last node, right? So now how you will access this thing? New node previous. So here I can write new node prev. Now address of the last node is 100, from where I can get this 100? In tail I have 100, so here I can write tail, right? So now here I have what? 100. Means now this node, this pointer is pointing to the last node. Next thing, this pointer, see, now the last node, the next pointer of the last node would contain address of the first node. So this address, that is 500, this should contain. How you will access this thing? Tail of next. So here I can write tail of next equal to address of this, that is 500, from where I can get 500? In new node I have 500, right? So here you will update what? Here you will write 500. So now this is not pointing to this node, right? And this is also not pointing to this node anymore. Fine. So now you can see here we have set this link, this bidirectional link. Now this is pointing to this node and this 100, so this is pointing to this node. So you can see this link is bidirectional, right? Next thing, last thing you need to update what? Head. Now head would contain address of this node because this would be the first node now. So head is equal to new node because address of the newly created node is in new node pointer. Fine. Now head is containing 500. So head is not pointing to this node now. Head is pointing to this node. Right. So I guess we are done with our insertion at beginning. See, now here it is not compulsory that you will write all the lines in this order. Fine. See, but in some point you have to take care like this. Here And first of all, you can update these nodes. The new node next, new node pointer means these two pointers. So here you can write new node next is equal to head, after that new node previous is equal to tail, like this, rather than head previous is equal to new node. After that you can write head previous is equal to new node. But what you need to take care is, this head is equal to new node, this you cannot update first here, because if you have updated head is equal to new node at starting here, means head is now pointing to this node. Now how you will access this thing? Fine, because we have broken this link, and this node is also not pointing to this node because we haven't set this link, right? So we cannot update head here. This you have to take care, these points you have to take care. After updation of this thing, head previous is equal to new node, after that you can update this head node, head is equal to new node, right? But it is not compulsory that you will write all the lines in this order as I have written. Fine. Plus one more thing what you can do, see here new node previous is equal to tail, here also new node previous is equal to tail, new node next is equal to head, new node next is equal to head, right? Both the lines are same. So what you can do, before if and else, here after taking this data, here you can write both the lines, this new node previous, this new node next here. Before if else, not after else. You can trace out this algorithm, this program, by writing these two lines here rather than if and else block. Fine. Plus second case is, you can trace out this thing by writing these two lines after else block. You will find out the difference, you will find out the mistake automatically. Fine. You can write down these lines before if else, not after if else, right? So now we will see how to insert a node here at the end of the list. So now we will define the function insert at end, right? This node we have created using these lines only. User has entered the data 8 here, right? Now we will insert here. What you need to change in this code, see, if head is equal to 0 means there is no node, then this would be fine, right? All the 3 lines would be fine as it is. In else part you need to change. First of all we will set these pointers. Now this would be the last node, right? So now the previous pointer of this node would contain address of the previous node, right? Because after inserting this, tail would point to this node, means tail is equal to new node. But before updating this tail, what you need to take care, you have to update this thing, because here I want to insert address of this node, previous node, and from where I can get this 100, in tail I have 100, right? So before updating tail, first set this link, new node previous. Here what you will write, new node previous. Here you will store what address of this node, that is in tail I have this address. So now here 100, right? This is pointing to this node now. Now this would point to the next node. So here tail next, tail of next would contain address of this node, the next node, because this would be the next node after this node. 700. So from where I can get 700, in new node I have 700. So now here I have 700. So now this is not pointing to this node. Now this is pointing to this node. Now we have set these two links. Now you have to set what? This link and this link, right? In new node next, here what you will store, the next pointer of the last node would contain address of the first node in doubly circular. Address of the first node is 500, right? Now here we don't have 500. This new node is pointing not to this now. Now the address of this first node is always in the head pointer. So here you will write head, right? So here I will write 500, means this is now pointing to this node. We will draw this link after setting this link. So now this first node, previous node of first node would contain address of the last node, right? So head of prev, head of prev. The address of last node is in new node pointer. So here I will write new node. It means now here I have 700, right? So now this is also pointing to this node and this is pointing to this node. So we can set this link, right? Like this. This link is bidirectional. This and this, right? To make it a doubly circular. Fine. Now last thing you need to update this tail pointer. Now tail would point to this node, right? In tail we will store 700. So from where I can get 700, in new node I have 700. So now in tail I have 700. So now tail is pointing to this node. And that is done. This is how you will insert a data a new node in the last of the doubly circular linked list. So I hope you got this coding. The diagram is little messed up, but I guess you are getting my point. Fine, how you will insert the data at beginning, at end. So now we will see how to insert a new node at any specific position. So now we will insert this node, right? And suppose position is 3, any position you can take. Position 3 means 1, 2, 3. Here I want to insert. You can say before this, after this, right? Here 3 and after that this would be 4th node. Position 1 means here at the beginning only, right? Now if I give position 5, it means there is no position 5. So it should print some proper message, that is invalid position, right? Now see how we will insert this thing. Now suppose position is valid, we have inserted position is 3. So this node I want to insert here at position 3, 1, 2 and 3. Now what you need to update, see here the previous node of this, previous pointer of this node would contain address of the previous node, that is address of this thing, right? That is 300. We will set this link, plus the next pointer of this node would contain address of the next node, that is 100. We will set this link, plus the next pointer of this node would contain address of the next node, that is this one. This would be the next node, that is 400. Here also you will store 400 because the previous pointer of this node would contain address of the previous node, right? So now you have to update 4 pointers here. Now see how we actually update these links. See, to insert this node here, obviously we need to reach till this position, na? Till position -1, because we need some pointer pointing to this node. If any pointer is pointing to this node, then only we can access this pointer and this pointer we can access using the new node pointer only. So we need some extra pointer. You have to traverse the list till that position. Suppose in my list I have 15 nodes and I want to insert at position 10. So first of all I have to reach till position 10, na? Or you can say till position 9, position -1. After that only I can insert there, because here we cannot directly access any node in the list. We have to traverse the list. You can access only sequentially at starting. In this case we have only what? This head pointer and this tail pointer value, right? Now see, we will take another pointer, you can say temp pointer, right? Now we will ask from the user for the position. So for that case also you have to take another variable. In that variable you will store the position, right? And for traversing we are taking another variable, that is I, and I am initializing this I with 1, right? Plus one more thing. Now suppose position is 5, then this program should print a proper message that this is invalid position, right? Now you have to find out the length of the list, right? You have to count the number of node in the list. Here the length is 1, 2 and 3. So valid positions are 1, 2 and 3 only, right? If position is less than 1, position is greater than this 3, greater than the length, then it should print invalid position, right? So here I am also going to call a function, that is get length function, and that function would return this length of the list, total number of nodes in the list, right? And that thing also we have discussed when we were discussing the implementation of singly linked list. Or if you want me to make a video on that case also, how to find out the length of the list, you can tell me in the comment box, right? So for storing that length of the list, I am taking a variable, you can say L, right? Now first of all I ask from the user for the position. So this is how using printf and scanf I have asked from the user for the position, and suppose user has entered position is 3, right? And we have a variable I is equal to 1. In I we have 1 only, fine. Now we will call a function, you can say get length, and that value I'll store in this variable, that is L. So here I am calling that function get length. You have to write down the proper code for calculating this value, right? The length of the list. Now get length function would return 3. The length is 3. So in L variable I have value 3, right? Now I'll check for the position. If position is less than 1 or position is greater than this L, it means here you will print a proper message, that is invalid position in printf. Else, if you can say if position is equal to 1, means here only I want to insert insertion at beginning. So here I will call that function insert at beginning, and that we have discussed already, right? You will directly call this function. Else, if position is valid, and position is not 1, like in this case position is 3, then what you will do? So now we will allocate memory to this node, because here we have only declared this new node pointer, we haven't created this node, right? So now we will allocate the memory using that malloc function, and the syntax, I guess everybody know how to write down that thing. And we will ask from the user for the data, which data he wants to insert using printf and scanf. I guess everybody know the syntax. And suppose user has entered -1. Now I want to insert this node here. Now first of all we will traverse this list till position -1 till 2. So now I have taken this temp and we will initialize this temp, right? And temp would point here, because from the first node only we are going to start our traversing, right? So this temp should contain address of the first node. So now after this only, after this declaration, after this line in POS I and this L, before taking the position, here only you can say what? Temp is equal to head. Here you can write this line. Now temp is pointing to this node, right? Now we will start a traversing. We will apply a while loop. While I less than position -1, till position -1 we are going to traverse. Till then we are going to move this temp. So temp is equal to temp of next, and what? I plus plus. So here you can see I value is 1, position -1, position is 3, that is 2, 1 less than 2, yes. Temp is equal to temp of next. Temp is pointing to this node, temp next is 300, so this 300 would be stored here now. So now temp is pointing to this node, right? 300. I plus plus, now I becomes 2. Now again check the condition, 2 less than position -1, 2 less than 2, no. So now we are not going to move this temp. We are going to stop, we will not enter this while loop, the control would go out from this while loop, right? As you can see we have reached till position 2. After this I want to insert, right? So now the coding I will write here. So now after this while loop, what you will write, how you will insert this thing here? See, first of all it's better to create these new links rather than updating the previous links, because for updating this you have to break these links. So rather than breaking the already set links, first of all set the new links. So update these links here, new node previous and new node next. So in new node previous, what you will store here, address of the previous node, that is this node 300. From where I can get 300? In temp I have 300. So here temp means this is pointing to this node. Now set this link, means how you will access that thing? The pointer to this node is new node. New node next is equal to, here I want to store address of the next node, that is 100. From where I can get 100? Here I have 100, and pointer to this link is temp. So you can access this using temp next. Temp next. So here I have 100, so this is now pointing to this node, right? Now update these links. See how you will access this thing. Here I will store address of the next node, that is 400. So temp of next is equal to new node, fine. Now here the previous pointer of this node would contain address of the previous node, that is this node, that is 400. But how you will access this part of this node? Is there any pointer to this node? We don't have any pointer to this node, right? See, don't consider this tail pointer, because suppose in list I have 15 nodes and now I'm inserting at position 3. So tail would point to that 15th node, right? We cannot access this node using tail. So I don't consider this tail. We cannot access this using this tail, right? Now see how you will access this thing. We don't have any pointer direct to this node, but address of this node is 100 and here I have 100, right? This pointer, this node is still pointing to this node, right? We haven't broken this link. So now can we access this part? Yes, we can access using temp pointer, temp of next. So here what you can write, temp next. It means we have reached, temp next means 100, means we have reached till this address. Once we reach till this address, right, then you can access this part or this part, any of the three parts, just by writing again an arrow and name of that part. Name of this part is previous. Now here I want to store address of previous node, that is 400. So from where I can get 400? In new node I have 400. Now here I have 400, so this link is no more and this is now pointing to this node. Now you update this thing, temp of next. temp of next. Here you will store address of the next node, that is 400. In new node I have 400. So now here also I have 400, so this link is no more, and this is also pointing to this node, right? And this is done. This is how we are going to insert a node at any specific position. Just you need to take care of this thing, that if position is 1, then you call that insert at beginning function, right? In that case we cannot write down these lines will not work. And now in main function you can call all these functions. First of all, create function, then you can call display function, then you can call insert at beginning, then insert at end, insert at position, right? Write down the name of these functions, right? And after that you can again call the display function, right? So that's all about insertion. In next video we will see how to delete a node from a doubly circular linked list. So I'll see you in the next video. Till then, bye bye, take care.